So as I said, the water content required to close a distance of half an inch after 25 is defined as the liquid limit. Now, I just said that, well, I count the number of drops. So I don't know how many number of drops are there. So definition of liquid limit is the water content corresponds to the closure of half an inch in exactly 25 blows. So this is kind of difficult to hit the target. What we do is we run an experiment at different water contents, and we interpolate. So before I go there, let's just look at the apparatus, and looks like the cross section. So as I said, this is the device we use. We have a certain standard cup. We place the soil. We separate using the screwing tool. So we have exactly a certain, you can see the wall at the deepest location. This is the structure. As we rotate the cram, then the sides come to slowly come together, and at some point they close by half an inch. At that instance, that's this half an inch closure. So at that instant we stop the test. This is actually an actual picture end of the test. You see a half an inch at the bottom. So what we do is at least 3 samples, but we typically do 4. It's shown 4, but at least 3 soil samples are prepared at different water contents. Let's say W1, W2, these are the water contents. Then what we do is we count the blows required to achieve a closure of half an inch for each content. Let's say for the first water content there was N1, so let's give a number for let's say for first water content we had, let's talk one. So this is the N1. Let's say this is the N2. Let's say N1 is about 32. So our lab data shows that the moisture content and N, moisture content versus N relationship. So these are the test 1, 2, and 3. Let's say we have 3 tests. So the first test is this one. The moisture content is about 30%, and N is 32. So based on this data. So this one, so moisture content is 40 moisture content. Obviously, as the moisture content goes up, you don't need as much drops to close. So in this case, we have N2 of 27. So for the third test, let's say this is the third test, N3, and for the, let's say the moisture content is about 44. We are increasing the moisture, and the N3 corresponds to 23. Now, let's say this is your lab data. What you are looking for is between these two, between 27 and you are trying to find the 25. What is then that corresponds to those? So somewhere between 40 and 44. You can see here somewhere between 40 and 44. Here you can just draw a best fit line. In Excel you can plot this in y-axis, x-axis. So in Excel you can draw this in x-axis, and x-axis is going to be logarithm of a, not the n, because the n changes logarithmically. So x is your logarithm of n, and y is actually the moisture content. So when you plot, draw a best fit line and estimate the n, the water content that corresponds to 25 blow. Okay, questions? All right. So let's go to a more high-tech test. I'm being very here. So plastic limit test. Let's talk limit, what it is. So it is defined as, so we are talking about the laboratory test now. What is the lab test? So the moisture content at which soil crumbles when rolled into threads of 1/8 of an inch in diameter. So the plastic limit is performed by repeatedly rolling an ellipsoidal soil sample by hand on a round glass plate. As the water evaporates during rolling, it starts to crumble. Obviously, if the soil is wet, it crumbles at smaller diameter. If it is dry, it can crumble at a large diameter. So the plastic limit is the water content at which soil crumbles at 1/8 of an inch in diameter.